Back to recording this. So again, dealing with a problem with fractions is not much fun. One thing we're going to do is to get rid of the fractions you can multiply by a lowest common denominator. So if we look at our denominators, 5, 8, and 10, we got to find something that they all go into. Okay, 5 times 8 is 40, 10 goes into 40, so that's going to be a good common denominator. So that's something that those would all go into. Okay, 5 goes into 10, but 8 doesn't. So you got to find something they all go into. Then we're going to multiply that number, okay, to everything. When you multiply fractions, you multiply to the top and then divide. So if we multiply 40 times x, that's 40x. And again, because that's divided by 5, you end up with 8x. Okay, likewise, 40 times 3 is 120. 120 divided by 5 is 24. Okay, tricky, but this minus in front actually needs to be distributed to both of those. So that becomes a -1 and a -x. Do the same thing. So 40 times -1 is -40. Divided by 8 is a -5. 40 times -x is a -40x. Divided by 8 is a -5x. Let's bring down my symbol. 40 times 1 is 40. Divided by 10 is 4. You don't have to show all of those steps, but hopefully that is able to show you kind of tracking what I was able to do. So multiplying by that lowest common denominator kind of makes for some ugly stuff going down, but when it's all said and done, now we have a problem with no fractions. One of the tricky things, again, that minus in front, you need to make sure and distribute it. Otherwise, you'll have the wrong sign here at that 5x. You'll end up with a positive instead of a negative like we're supposed to have. Anyway, from here, it solves like a typical regular algebra problem. So we can combine our like terms. 8x minus 5x is 3x. 24 minus 5 is 19. If we need to get the 19 to the other side, we add the opposite, so subtract. 4 minus 19 is -15. 5 divide. X is greater than or equal to -5. Now, another thing to be aware, so far all of the problems that I have picked end up with pretty little whole number answers. That is not always the case. Okay, if you get some crazy fraction answer, that is entirely possible. In fact, my math lab loves to give ugly answers, which I don't necessarily like. So if you don't get a pretty little whole number answer, don't think you're doing something wrong necessarily. Maybe you are, maybe you're not, but anyway, that's not just a straight up indicator. From there, you can also do the graph and the interval notation. I said I'm going to show it, but I'm going to because what's the difference? Okay, so greater than or equal to -5. Squared off bracket, shades to the right. And again, the interval notation would say from -5 to infinity. So the -5 gets a squared off bracket. Infinity is always parentheses. That is literally as hard as it gets in this unit. However, my math lab does throw a couple of problems like that in here. So just be aware. Most of the problems are way more straightforward. But just so you're aware, that can happen. Another thing that can happen when you go to solve All right, say we have a problem like so. Everything looks fine. To get rid of parentheses, we distribute. So again, you multiply whatever's outside to everything in. 7 times x is 7x. 7 times -1 is -7. When we go to solve, we're going to subtract 7x. But, oh no, all of our variables drop out. What I'm left with is 1 is greater than -7. Okay, if I don't have a variable, I'm no longer solving. What I have left to do is I need to look at this problem. Is it possible for 1 to be greater than -7? In this case, yes, that will happen every single time. So kind of what's saying is, basically, no matter what you put in for x, this is going to work. Okay, so regardless of what x is, you're going to end up with all real solutions. If you have an all real solution problem, interval notation wise, that reads from -infinity to infinity. That means you hit everything from forever small to forever big. If they ask you to graph that, you would literally graph the whole number line. Everything gets graphed.
Is that little R thing that you drew important?
That just means all real numbers.
Okay.
So it's a capital R with an extra bar. And what that means is every possible conceivable number that you could imagine. My math lab is going to want to see it like this, the -infinity to infinity. So this is the better notation, but this is just a math notation. So yeah, the capital R stands for all real numbers. This is the one that's going to be the more important right there. If I did a similar problem and say we ended up with something like this, 3 is greater than 5, which is never going to happen. That is not at all possible. Okay, that is a no solution situation, and that's the symbol you would use there. So if something will never work, then we say there is no solution, or we use the symbol for the empty set. Okay, so that's just a couple of things that they will do. So I'm going to again throw back up. The ugliest problem they could possibly give you is one of these fraction ones. Okay, again, walking through to get rid of the fractions, we multiply by the lowest common denominator. And again, I'm still recording this, so you can go back and watch. Also, I've uploaded a video that has some different examples, so you can go back and watch those as well. And then be aware, every once in a while, they may throw you a curveball where you could end up with all possible solutions from -infinity to infinity, or a no solution. So again, the graph of no solution is nothing gets shaded. You just have a number line with no shading anywhere on it, because no solutions exist. Now, from there, I'm going to transition into 2.5, which 2.5 is basically the same stuff, just they're going to give you more inequalities per problem. So 2.5 deals with what we call compound inequalities. So what they're going to do here is they're going to give you multiple inequalities per problem. Okay, again, to kind of illustrate what's going on, I'm just going to focus on like the solution side of things, then I'll practice, or I'll show you a couple examples of some problems that we need to actually solve for. But one of the keys to compound inequalities is right here. They're going to use the word and, or they're going to use the word or. Okay. So this is two examples of a compound inequality. Okay, again, you're going to have two inequalities at the same time, and then you're going to have to focus on what's really important is whether they say the word and, that says and, if you can read my crappy handwriting, A-N-D, so that's and that's an or. It's extremely important that you understand that when and is present, both things have to happen, okay? We're looking specifically for overlap. It has to satisfy this, and it has to satisfy this. It has to do both, okay? So graphically, what that looks like, okay? We're talking about 3 and 5. Also on a number line, it's important to remember smaller numbers go to the left, bigger numbers go to the right. If you invert those, that's going to screw stuff up. So pay attention there. So the smaller number goes to the left, bigger number goes to the right. Okay, so if we're talking about numbers bigger than 3, okay, that would be parentheses to the right here. So that's this one. So x is greater than 3. That looks like that. Okay. And then x is less than 5. Okay, open parentheses. Looks like that. So the only numbers that satisfy both, okay, the overlap, is those ones right there in the middle. So numbers bigger than 3, so like 4, okay, or 3.5, 3.5, something like that. Okay, that's bigger than 3, but also smaller than 5. So your solution set looks like this. It's everything between the 3 and the 5. It's where those two graphs overlap. Okay, you see double lines here. Everything over here just is bigger than 3. Everything over here is just smaller than 5. Only the stuff in the middle satisfies both. Okay, and again, I'm drawing with a Sharpie, so it's kind of tough to tell, but I used rounded parentheses from 3 to 5. Interval notation reads just like that. Okay, we would say open parentheses from 3 to 5. Okay, or means just that. It means either or. So if it satisfies this one, great. If it satisfies this one, great. All of these solutions work, as well as all of these solutions. So again, on your number line, if we're talking again from 3 to 5, everything greater than 3 looks like that. Everything less than 5 looks like that. So technically, every single possible number will work, because every number smaller than 5 works, and every number bigger than 3 works. We end up shading everything. So like a million is bigger than 3. -10, well, that's smaller than 5. So every conceivable number works in this situation. So our interval would say from -infinity to +infinity. That's that all real number situation. Everything will work. So it's extremely important. If you see an and, you are specifically looking for overlap. If you see an or, you're looking for either or. So it's all of the one as well as all of the other. Okay, I want to show a couple other situations doing similar type of stuff. So if we said x is less than 3 and x is greater than 5. Again, it's important, smaller number to the left, bigger number to the right. Everything smaller than 3 goes this way. Everything bigger than 5 goes this way. And again, specifically that and is looking for overlap. Are there any numbers that are both smaller than 3 and bigger than 5? No. Okay, number smaller than 3 over here, bigger than 5 over here. These two lines don't intersect. They don't overlap anywhere. There are no numbers that work. So again, this is a no solution situation. Nothing gets shaded. Okay, again, for an and problem to work, it has to satisfy both at the same time. This doesn't work. Okay, compare that to doing the exact same thing, just if this was an or. Okay, again, everything's smaller than 3 goes that way. Everything's bigger than 5 goes that way. Again, this is now an either or, so I need to make sure I'm shading everything smaller than 3. So that would be all of these. I need to shade everything bigger than 5. That would be all of these. Now, interval notation wise, this is a little tricky to write. But again, if you're looking at the graph, it reads just like the graph. So read the graph from left to right, and that's kind of what we're going to write here. So what is my smallest possible value? Negative infinity. So we're going to go from negative infinity all the way up to 3, not included. And then we're going to use this symbol here. That means or. That's my or symbol, that U looking symbol. And then we're going to go from 5 to positive infinity. So again, the interval notation reads straight from the graph. So we're going from negative infinity to 3. And then there's a gap. That's kind of what that U shows. Okay. And then we're going to go from 5 to positive infinity. So this is what that interval notation would look like. There's one other situation I want to look at, and then we'll do some practice problems, and then we'll finish this up. We got about 15 minutes left in class, which works out really good. So the last situation is we have arrows kind of going in the same direction. So again, I'm going to keep sticking with 3 and 5. Tell you what, I'm going to throw these as equal twos just so we can do some closed bracket, same stuff. Anyway, so if we were supposed to solve x is greater than or equal to 3 and x is greater than or equal to 5. Again, extremely important, smaller number to the left, bigger number to the right. So when you're doing these, make sure you put your numbers in the correct order. They don't always put the smaller one over here. They don't always put the bigger one over here. We'll do some practice problems and we'll see that. Okay, everything bigger than or equal to 3 goes that way. Everything bigger than or equal to 5 goes that way. And again, specifically, the word and means overlap. It's only the ones that work for both. So over here doesn't work for anything. In the middle here only works for the top line, so greater than 3. But anything bigger than 5 works for both. So numbers bigger than 3 and bigger than 5 would be all of these numbers here. So 5, 6, 7, 8, 9, 10. So anything bigger than 5 is also bigger than 3. So that satisfies the and there. So again, my interval notation would say from 5 to infinity. And then again, because it's greater than or equal to, that's why we have these squared off bracket. Also remember, infinity always gets parentheses, like so. Okay, finally, same game, just dealing now with or. Again, greater than or equal to 3, looks like that. Greater than or equal to 5, looks like that. If it is an either or, then again, everything that should get shaded gets shaded. So we need to include everything bigger than 3 as well as everything bigger than 5. So that works. So everything bigger than 3 catches every number that is greater than 3 or greater than 5, because if a number is greater than 3, okay, then it's going to at least be greater than 3, and would include everything greater than 5. So again, your interval notation would then say from 3 to infinity. So that's just some examples of the different scenarios you could see. Again, pay close attention to the words and or. Again, and you're looking specifically for overlap. If they're going in opposite directions, you're going to shade where they both shade, typically like right there in the middle. If they're going in opposite directions, it's an and, that's a potential no solution. If it's an, anyway, or we went over all these different scenarios. So this is basically all of the different kinds of solutions you can get. Now, again, they're not typically going to give you the answer and be like, hey, graph this, or give you the interval notation. They're typically going to ask you to solve some stuff. So they'll do something like this. So x plus 5 is greater than or equal to 5, and x plus 10 is less than or equal to 9. So we're going to solve and then graph both of those on the same number line. So solve them individually, then graph. Okay, again, these are fairly simple problems. So to solve, we want to get the x by itself. The opposite of adding 5 is to subtract. So x is going to be greater than or equal to 0. Likewise here, to get rid of the 10, I'm going to subtract. So x is going to be less than or equal to -1. Okay, go ahead and solve both because it's important whenever you go to put these on the number line, the smaller one has to go to the left. So it's important. In this case, -1 is the smaller solution. So that has to go over here to the left. In this case, 0 is the larger of those two solutions. So 0 is going to go over here to the right. Then we can look for what's going to get shaded or whatever. Okay, so x is greater than or equal to 0. It's going to be a closed bracket, shade in that direction. That's everything greater than or equal to 0. Less than or equal to -1 would go in that direction. Again, this is an and problem, so I'm looking for overlap. Do either of these lines cross over the other one? Is there any overlap? No, there is not. So this is an example of a no solution problem. Okay, so that's very typical. They're going to give you two problems, then they're going to give you an and an or. You're going to solve and then graph both. And again, your solutions will end up looking like that other examples that I went over. And then they're going to have a bunch of different kinds of problems. They do less fractions with these, which is nice. They actually do more straightforward problems, which is convenient because it's not about the solving. In this case, they want to double check and make sure you understand the and the or. The only type of problem that I haven't talked about that I want to bring up next is they could write the compound inequality like this. Okay. If they give you a problem like this, this is still a compound inequality. You can tell because you have two inequality symbols. And basically what this means is, okay, we're going to solve both. So we're going to say 0 is less than or equal to 3x minus 5. And, okay, 3x minus 5 is less than 7. So when they write the problem like this, you don't see an and or an or, it's just written like this. It is an assumed or implied and. This is an and problem, always. Okay. If they want an or, they'll write the word or in here. Okay. They'll give you two separate problems and they'll write the word or. If it's written as one compound inequality like this, it's an implied And to solve it, I would probably go ahead and split it up just like I did. So again, to solve, we're going to add 5 to both sides. 5 by 3. X is greater than or equal to 5 thirds. Now, I'm actually going to flip this because I like my x's being on the other side. So x is greater than or equal to 5 thirds. Pay attention to how the symbol relates to the x. Okay, it's saying the x is greater than. X is greater than. Okay, same game. To get rid of the -5, we're going to add 5. The x is less than 12. Divide. X is less than 4. So if we graph, 5 thirds is the smaller answer. It has to go to the left. 4 is the larger answer. It goes to the right. Everything greater than or equal to 5 thirds. It's that way. Everything less than 4 goes that way. Again, the and implies overlap. We have 2 lines here in between, so we're going to do everything from 5 thirds to 4 included. So my solution is all of this stuff in between those two. So my solution is from 5 thirds to 4. Again, 4 was just less than, that's why it's a rounded parentheses, not included. The 5 thirds was greater than or equal to, that's why you get these squared off bracket. And again, interval notation reads just like the graph. And that's basically as difficult as that one gets. They do throw a couple of fraction problems in there, but by and large, it stays pretty close to the straightforward problems. So again, you're going to want to go in and you're going to practice the My Math Lab homework problems. I believe there's 12 problems in each. Remember, you get 3 tries. So if you don't get it on your first try, make sure you're answering all parts. If you need help or go over anything, you can always email me. I'll stick around until 8:15. So we've got another 7 minutes in here. If you want to stick around and ask questions, that's great. But if not, you are free to go. Covered all the stuff that I'm going to cover for tonight. Next Thursday, we'll meet same time. We'll cover from 2.6 and 2.7. I'll try to make sure the Zoom lasts the whole time, so we won't have to do the pause and jump back on later, because I know Waynesville and Republic weren't able to do that. So I don't know why it kicked me out, but it did, but hopefully we'll get that all fixed and rectified from there. But anyway, let me know if you guys have any questions. Like I said, I did post a video in Canvas, so if you want to see some different examples or you want to have me talk a little bit slower, you can go back and rewatch that video or watch that new video. Remember, you've got practice in that My Math Lab thing, but that's all I got. So if you're done, you want to go, you are free to go. I appreciate it, and we'll see you guys next Thursday.
That practice isn't due today?
No, it won't be due. Nothing's due today. Nothing is due until like 3 weeks, something like that. Yeah.
Still gonna do it. Yeah.
The sooner you can get it done, the better. It's
That's my class.
yeah, number one, it's a number of problems, like 12 problems. It still takes a while to do. Like I'm pretty good at this, and it still took me like 30 minutes. So it's going to take a little bit, especially if you're not super great at math. But while it's fresh in your mind, it's going to go faster and it'll help it stick because
Yeah,
you're
I'm
practicing.
remembering a lot of this from algebra in high school.
Yeah. Well, you guys have, some of you guys have the benefit of, if you're fresh out of high school, you probably did this relatively quickly.
Well,
There are other students who haven't been in school for a while. And if you haven't been in school for a while, it's like, I don't remember seeing any of this. So
I took a college algebra class from Springfield OTC with Mr. Aberley, and this was online in my second semester of my senior year, so I didn't know anything.
yeah,
And I'm like, I dropped out by the time April came because I was able to,
yeah.
and yeah, I wasn't even passing.
Well, I'll do my best to help you out, but as you have questions, ask and we'll get it all taken care of.
There's gonna be something on there every day or no?
No, nothing. Just as we do stuff on Thursdays, that's when it's going to come up. Okay, see you, Zach. Okay, like I said, that's all I got. So you guys are done. You can log off. If you have questions, go ahead and ask them. Great. Bye, guys.